Okay, so what is the measure of each interior angle of a regular polygon with 12 sides? Okay, so the measure of each interior angle of a regular polygon with 12 sides. How are we going to do that? A regular polygon with 12 sides. So first off, what is a regular polygon? It actually means a perfect polygon. Regular means perfect, means all sides are equal, all angles are equal. So a perfect polygon is one that's a perfect shape. All the sides and all the angles are exactly equal. So it's a regular polygon. It's called regular, meaning perfect. All the sides are regular. There's no differences. There's no variation. All the sides, all the angles are equal. So if you have a perfect 12-sided polygon, how big is each interior angle going to be? Well, if you go to the notes, so again, I refer you to the exam 1 notes. Here they are. Here's the top of them anyway. So exam 1 notes, this is at the top of our unit 1 module in the Canvas course shell, right at the top, exam 1 notes. You roll on down, we got the formulas, and here they are. So there's the one. I've got it actually already over here for you. So let me just refer to it here where we can look at it and fool around with it. So this is what we need. N-sided regular polygon. All sides and angles are equal. Excuse me. Each interior angle, each exterior angle, and each central angle. And they're showing us in this picture. I got this off the internet. What they are. Central angles right here in the center. So if this is the very middle. So this, by the way, yeah, let me mention this. This is a regular, what is this one? A pentagon. So it's regular, meaning it's all the sides are equal. All the angles are equal, right? That's a regular shape, isn't it? And then let me show you one that's not a regular shape. Like what if we went boom, and then boom, and then boom, and then boom, and then boom. So there's one that's not regular. I want to make sure it's clear what we're talking about. So the sides are not equal, are they? Right? Some of the sides, some of the angles are not equal. These angles are not all the same angle as well. Angles are not equal. So that's the difference between a regular polygon and a polygon that's not regular, right? So regular means all the sides and angles are equal. It's a perfect shape. So this is a perfect shape polygon. Everything's equal, perfect balance. Whereas over here, that's not regular, not a perfect shape. Okay, so here's the formulas we need. Which one are they asking for? This one, interior. So there's our formula. Did 2 formulas. N minus 2 times 180 over N. So we come here and go, okay, we can do this. Each interior is N minus 2 times 180 over N, where N equals the number of sides. See that in the formula up here? It says N-sided. So, all right. So in my case, it's 12. So plug in a 12 there, and they're going to plug in a 12 right there, and right there, going to plug in that 12. So I get 12 minus 2 times 180. And so that is what? 10. 12 minus 2 is 10 times 180 over 12. Hit the buttons on your calculator. That's exactly what I'm going to do. 10 times 180 with whatever numbers you have. I'm getting 150 degrees. So 150, they've already got the degree symbol there for us. So 150 degrees. So that means each angle, each interior angle in a 12-sided shape. I'm not going to try to draw a 12-sided perfect polygon, but they're telling us in a 12-sided perfect polygon, every one of the interior angles is 150 degrees. So there we go. So you just plug into this formula, and it's going to give you what each interior angle is. 150 degrees. Now, so there's the answer. We've got it. But I don't totally like to do math like that. I mean, it's fine and everything, but I don't want to give it to you like magic. I hope you don't want it like magic. Just, math is a bunch of formulas. You just plug in. Nobody knows where they come from. Let me show you really quickly where they came up with that formula. It's not that hard. You'll be able to follow it. And I want you to, I think it's satisfying to know, okay, how'd they come up with that? It's like a magic trick all of a sudden. How did they come up with it? Well, it's not that hard. First off, what's an interior angle? Notice interior angles are inside. These are the interior angles. Exterior are outside of the polygon. And central or right, if this is the center, it's right there. So first off, those are the three kinds of angles we have formulas for. Central angle right in the center, interior angle right here, and then exterior angle right there. So how'd they come up with these? Well, I'm just going to show you the interior one. How'd they come up with that interior angle formula? Well, what they did is, it's actually not that bad. They reasoned like this. They just said, okay, so if we have a triangle, we already know there's 180 degrees in every triangle, right? There's a funny looking triangle I made there. Here we go. Every triangle has 180 degrees. Total, inside, interior. Say interior, use the same word they use. Oops, I'm getting scribbly here. Interior angles. So these three interior angles must total 180 degrees every triangle. That we already know. You can see that really easily if you just rip out the three corners of any triangle and line them up. They'll make a straight line. You can see that. Anyway, let's move on. So then what if you have like, let's say a four-sided. Wait, I don't want to do it all perfect like. That's terrible. I'm having trouble doing four-sided shape here. There we go. What if you just have any old four-sided shape? What do the four interior angles add up to be for four sides? Well, remember we learned last time that you could, if you want to know what those four angles are, you could just put a line, fill in a diagonal, and say, oh, there's 180 and 180 because it's two triangles, right? So in other words, four sides is a four-sided object is 2 times 180. I don't even care what the answer is, 360, but who cares? I'm mainly looking for the pattern. And then we said, okay, now what if we go to one, wait, let me use the tool here. 1, 2, 3, 4, 5-sided shape. Can we do the same thing? We can. Start with one dot and start making diagonals. Boom, boom. So this triangle, so what we're doing is we're just breaking it into triangles, huh? So if you have 5 sides, then you have 3 180s, don't you? 3 triangles are in there. Let's do one more. If you have 6 sides, so 1, 2, 3, 4, 5, 6. That's kind of terrible, but anyway, let's say boom right there. Yeah, that's just too bad. I did a bad job on that one. Let me try again. And there's bad, and there's acceptably bad. Okay, so 1, 2, 3. Oh, I'm running out of room. 4, 5, 6. That's better. Okay, sort of missed at the end there. There we go. So what if we have 6 sides? 6 sides. Again, let's fill in the diagonals. Make from one point, you just start making triangles. So you're getting the idea. There's 180 in each of these triangles. So 6 sides is 4 times 180, etc. So you see the pattern now, right? I hope you see the pattern. So in other words, because now what I want to do is I want to be able to go down and say, what about for n sides? Does everybody see the pattern? For 4 sides, there's 2 180s. For 5 sides, there's 3 180s, right? Everybody seeing this? For 6 sides, there's 4 180s. So what's the rule? What do you do with this number to get that number? This number to get that number? This number to get that number?
You subtract 2.
Yeah, it's always subtract 2. So therefore, if you start with n, what's it going to be here? What times 180? N subtract 2? That makes sense? See how that's exactly the pattern? So if you have n sides, it's going to be n subtract 2 times 180 because however many sides you have 2 less than that triangles, don't you? Right? If you have 6 sides, that gives you 1, 2, 3, 4 triangles. If you have 5 sides, it's 1, 2, 3 triangles. If you have 4 sides, it's 2 triangles, etc. So if you have n sides, it's n minus 2 triangles, n minus 2 180s. So there's the formula for the total. Now that's the total degrees. That's the total. So that means, let's go again. So that means if you have a polygon, let me draw one again. Try to draw. Oops, I'm not using the tool. Well, it's not the best. But pretend that's perfect shape. It's not a perfect shape. Let me try again. Boom, 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 boom. Close enough. All right. So let's pretend that's perfect. Okay. So how much each? So the total of all 6 angles inside equals n minus 2 times 180, right? The total of all 6 angles, or n angles, let's just call it n. Total of all n angles is n minus 2 times, so that's the total. So what if I what if I told you, I don't even know what the answer is here, but what if I told you, it's 800 degrees or whatever? I don't even know the answer. I'm just making up numbers right now. What if I told you, okay, it's well, in fact, I could figure it out. I think it comes out 720 degrees. So what if I said, okay, there's 720 total degrees. That's the total of all 6 angles in a perfect hexagon. So how much is each angle? Could we figure that out? Each interior angle equals, what do you guys think? If I said all of these 6 angles, 1, 2, 3, 4, 5, 6, right? If I plug in 6 here for 6 angles, then you get 4, 6 minus 2, 4 times 180, which comes out 720. That's how I got the 720. That's the total, right? I used that formula that we said, you can see it right here. For 6 sides, it's just 4 times 180, which is 720. So for a perfect hexagon, regular hexagon, the total degrees inside, the total is 720 degrees because it's 1, 2, 3, 4 triangles, isn't it? It's 4 triangles. So the total degrees inside is 720. So now the question is, how much is each of those 6 angles? Each of the 6 angles. If altogether all 6 of them total 720 degrees, how could we figure out what each of them is if there's 6 of them totaling 720 degrees?
What do we divide by 6?
Beautiful. Exactly, right? You just divide by 6, which comes out 120. So we know each of these must be 120 120 degrees, 120 degrees, 120 degrees, 120 degrees, 120 degrees, 120 degrees, right? That's beautiful. Good thinking. Yeah, exactly. So that's all you need to do to find out each interior angle is just find the total, because you know that it's made out of a bunch of triangles, right? So it's 4 triangles totaling 720. And then if you want to find each angle, you just divide by how many you got. So that's why the formula is the total, or we also call it the sum of all interior angles, is n minus 2 times 180 times 180. And then we have each interior angle. Each interior angle is n minus 2 times 180, and then you divide by n. We did 6 because we had 6 in particular, but in general, you have n sides. So you see, you just divide by the number of sides. That's how they came up with that formula. Does that make sense? It's not some amazing deep thing. They just looked at polygons and they said, well, it's n minus 2 times 180 because that's a bunch of triangles. And then if you want to know each angle, you just divide by the number of angles. Divide by n. So there it is. I want you to see the derivation. That's how they came up with that formula that I gave you in the notes. So that's more than you need for this problem, but I want you to see the derivation. There we go.